Good afternoon, everyone. Thanks, Dawn, for letting me step in. My name's Ian Salter, and I'm an observational biogeochemist, but I'm also responsible for the observation service in Banyuls. So I'm very grateful to have this opportunity to present our site. So we have several institutional partners. We're part of a larger network in France called SOMLIT, which is a network of coastal observatories with standardized protocols. I'll mention that in a bit more detail later. We're also part of Assemble and EMBRC, which provides funding platforms for people to come to the laboratory in terms of marine observation. And we also have several international partnerships with the University of Delaware and also with the University of Concepcion in Chile, and these are all founded around our observation activities. So to just briefly describe the site, our observation sites are located in the northwest Mediterranean. So this is an oligotrophic, low productivity ecosystem, and its main defining characteristic really is that it's under severe phosphorus limitation for most of the year, and it's also strongly influenced by the northern Tramontane winds from the continent, and there's a significant input from the Rhone River. So it's a very dynamic site, which makes it very exciting to study. And our observation activities are mainly centered around one-dimensional time series, which we visit on a weekly to fortnightly basis, measuring a range of different parameters. And we also have some high-frequency buoy systems that are moored at the site, where we get a continuous stream of data on a much narrower set of parameters, but much higher frequency. So just to show you some data, one of the advantages of this site is that we now have around 15 years of data which we've collected, which has allowed us to start and construct climatologies of certain biogeochemical parameters, and that gives us quite a good description of the site. So here are the climatologies from the last 15 years of data for certain of the parameters that we measure. So you can see from the chlorophyll A data, for example, we're in quite a low productivity system, and the phosphorus data is very often close to the limit of detection. So we're really working in an oligotrophic environment. One of the advantages of having these long-term data sets and these climatologies is that we can start to look at anomalies from year to year. And I think this is something that is worth considering in the context of these long-term observatories. And I've just given this example of chlorophyll here. So the solid grey line there is the climatology, and the dashed lines are the relative errors on that. And the green data is from 2011. So you can see, for example, in November, we had a huge perturbation in chlorophyll. And if we go out and take a sample at that point, it's very useful to know what state the system's in relative to some kind of reference state. And that reference state can only be defined by an extended period of observations. We actually have three sites: a coastal site, a site on the continental shelf, and then an offshore site. And the sampling varies from weekly to monthly. One thing I'd like to point out is we measure a set of core parameters which are standardized within the SOMLIT network. In addition to that, we have rate measurements which are more specific to the research activities of the lab, so bacterial production measurements, occasionally primary production measurements. But I'd like to just point out this involvement with SOMLIT because I think it's quite important, especially considering the discussions we've been having about metadata this morning. So one of the big advantages of this site is we have standardized protocols across all of these sites in France, and every single measurement has a quality code associated with it. And I put up a list of the quality codes there, so we've kind of covered just about every scenario you can imagine. But the good thing is that when we are then using this biogeochemical data to explain genomic data sets, we can also filter our biogeochemical data by a certain set of standards. So whether or not we have a replicate measurement, sometimes we have a measurement that seems good, but it's quite unusual for that time of the year, and so we could say it's a doubtful measurement, for example. And this is kind of maintained by having inter-laboratory comparisons where we all measure the same parameters, and so the protocols can be compared between stations, and they're continuously improved. 5 minutes goes really quickly, doesn't it? So this is just a quick example of some of the genomic type of work that we've started. We've started looking at prokaryotic diversity. So here you can see this is just diversity measurements showing the seasonality of diversity over time. And we've kind of climbed into more detail looking at specific groups. So I'm going to stop on 6 seconds. I'm the champion. So yeah, thank you.